In the meantime, we switch over to Mark Kragh from Off-Grid Europe with a more traditional approach to stabilize the grid.
Hello? Cool. So forward and backward. Cool. Hello, everybody. My name is Mark Kragh. I am one of the founders of Off-Grid Europe. Together with my wife, we've been existing for the last 10 years as a company, growing quite nicely. Here's a little introduction to what we've done over the last few years. At the moment, we have basically two facilities. We've got one in Fullendorf, where we're doing some production, assembling containers, distribution boards, do a lot of software. And we also have a daughter company in Africa, in Senegal, where we're making actual installations. So we manufacture stuff in Germany, we send it to Senegal, and then we have an installation team. So altogether, about 55 people in Senegal, 25 people in Germany, and a bunch of freelancers. So we've done installations worldwide, but right now we're more focusing on industrial scale rollouts, where you establish an office in a country and then effectively do hundreds of installations in that country. As you can see here. So right now we've electrified about 150 villages, installed a lot of batteries. I think these numbers here are a bit low, actually. Flagship project is in Senegal, as you can see right here. And this is what one of our typical installations look like. All the steel structure and everything that goes around it is made by us. We've installed everything inside the container. We like to get our hands dirty. We like to manufacture and engineer stuff. But today I want to talk about grid stabilization, because I don't know how many of the people in here have traveled to places where you don't have electricity. You're sitting there in your hotel room or you're visiting somewhere and all of a sudden your power is gone, right? Your air conditioning goes off, your electricity goes off, whatever, and you think like, why is this really happening? It's more complicated than thinking like, why did electricity turn off? There's a whole bunch of reasons why this is happening. It could be no fuel, it could be an overload, it could be an underload, you know, there can be an imbalance in the phases, that sort of thing. And if you want to think about like how we're going to deal with that problem of these emerging market grids, this is not really so much a problem that you would have here in Europe, where the voltage is very stable. Different problems here. But when you're dealing with a more unstable grid, you have to be thinking about like what kind of hardware are we installing here to deal with these issues, these outages which are happening. So I'm going to give an example here of a situation in Senegal. I was out here in Kaffrine last year looking at a hospital. They're building 6 new hospitals, huge hospitals, European-style hospitals. Everything is completely up to date. Scanners, air conditioning, everything you'd expect. The system is installed on a grid in a community with maybe only 20,000 people in that town, to take the whole region, patients for that region. The hospital destabilizes the grid, yeah? So you go from this graph is not from that grid, I just say, just disclaimer, yeah? But it kind of shows the problem, what's going on here. You can see we've got a graph here where you have your voltage on the medium voltage line here on the right-hand side, and you have your power on the left-hand side. Okay, so that's watts. It's a large number, right? So it's megawatts, of course. And that's volts. And throughout the day here, you can see that you actually have complete outages in the power in this particular network here. And the voltage is fluctuating all over the place wildly. It's causing many, many problems. First of all, people are losing power. Also, equipment can be burnt out. You have a massive spike of overvoltage, or you have an undervoltage, can create problems like excess current and so on. So what do you need to do to this? Well, really what you want to do is, you want to look at, what are we going to do? We're going to upgrade the network. We're going to put more high voltage, medium voltage, low voltage lines in. Very expensive. A lot of people have to be involved in it, cost tens of thousands, if not millions per kilometer. What you can do instead, of course, is put what's called battery solutions in the edge of the grid, together with solar. And this can basically help fix the problem of grid stability to quite some degree. You can shift loads from the start of the day. If you have a large flow through the, I don't know, the national grid, for example, you could ease the burden in the peak of the day, and then in the middle of the night, you can take that electricity back into the battery. And by doing that, you can maybe have less infrastructure, what's it called, cost and development cost to the grids, and invest instead in renewable energy. So how does that work? Well, you come with a container, like what one of the ones we have, or other companies also. A few megawatts of power in one container. It's scalable. 1 kilowatt, 1 megawatt, 1 gigawatt. Depends on your solution. Where are you? What's your needs? You have to do an evaluation. It's a financial case at the end of the day. So you have to do return of investment, get some grants, whatever, in order to make that work. But it's totally doable and very scalable, and it's fast. Much faster than making a massive power line. Another thing you can do with this is you can have productive use of energy. Now, one of our products that we're going to be launching the early start of next year is a cooling storage with about 150 kilowatts of solar system on the roof of a cooling house where you're producing power in real time to cool down agricultural produce. 3,600 cubic meters of cooled space, taking in 100 square kilometers of agricultural produce. And when there's no need for that cooling, or a part of that cooling space is not being used, you can actually export that electricity to the grid. And on top of that, you can actually use this storage of battery that you have there and these powerful inverters to go and stabilize the grid. So you have like 3 or 4 different benefits from this kind of productive use of energy. And this is just one of many ways to be looking at energy and how we should look at energy in the future. In our case, we have battery storage systems. Again, a lot of companies have battery storage systems, so there's nothing special there. But we use LFP technology. I think what we focus on a lot is the inverter. So we don't just have a standard inverter that follows the grid. Our inverter is very powerful, super fast reacting, sees a small instability, immediately goes in and throws in corrective power or removes some power if that's needed. And that's really what you need for unstable grids. For a stable grid, it's different. You can have a transformer-less inverter. You can do this in real time, not so much of an issue. But for unstable grids, you actually need an off-grid product. And that's why, as Off-Grid Europe, we're now starting working on grids. We also have our own controlling and software platform. And our company basically is an end-to-end service. Yeah, planning all the way to operation and maintenance. And yeah, that's Off-Grid Europe and Off-Grid Africa. We are in the process of, well, let's see, but we're probably founding Off-Grid Angola and Off-Grid Morocco, the next few companies that are coming up with this kind of service that we supply. And yes, if anybody has any questions, we have a stand over there. So thank you very much.